Welcome to this video on the development of the model of the atom. This is for AQA Physics and Chemistry. First of all, just going to talk you through some different aspects of what we're looking at here. So first of all, the key thing when we're looking at the development of the model of the atom, the reason it developed over time is due to gaining greater amounts of evidence and evidence of different aspects of the atom and how it needed to change. Now, first of all, as you can see here from this sense here, both the discovery of the electron, before the discovery of the electron, atoms were thought to be tiny spheres that could not be divided. So an atom was as small as it got, and it didn't get any smaller. But actually, what ended up happening is a gentleman called J.J. Thomson made the discovery of the electron in 1897, and that led to a model of the atom being proposed that actually was different to just the idea of a sphere. So that model was known as the Plum pudding model. So really simply, what we had was a what was known as a ball or a sphere of positive charge. So a sphere of positive charge, and inside that, dotted around, was our electrons. Okay, so they were dotted around inside that ball of positive charge like plums in a pudding. And that was the initial model of the atom. Now, as time went on, more evidence was found, and then that led to changes in that model of the atom. So there was an experiment known as the gold foil experiment or investigation, or the scattering experiment. And this was by a gentleman called Ernest Rutherford. Now, as you can see here on the diagram, what we had was a radioactive source, and that radioactive source sent out beams of alpha particles. Now, what an alpha particle actually is two protons and two neutrons. And that is the nuclei of a helium atom without the electrons. So if you've got two protons and two neutrons, overall, that has a positive charge. And that was very important as to one of the aspects of the evidence that was discovered from this investigation. So as I was saying, there's a beam of alpha particles that are being sent towards some gold foil. And the gold foil, obviously, as an element, contained a nucleus and contained the atoms as we know them. Now, what happened was three different things that were seen. Now, a lot of the alpha particles, as you can see from this statement here, travelled straight through the foil, undeflected, didn't repel, they just travelled straight through. Now, that was very important to understand, because what that allowed us to understand is that the atom is mostly empty space. A huge amount of the atom is empty space overall. So that was one of the things that we discovered. Another thing that was discovered was this statement here. So some alpha particles are deflected by small angles. Now, I would actually look at using the word repelled here as well, because what happened, as you can see, is some of them went in and then repelled away. Now, what that told us, because as I stated earlier, an alpha particle has two protons and two neutrons, it is positive, and it went towards and then repelled away. So what that told us is the nucleus, this central part, had a positive charge, because what happens if you've got a positive charge, two positive charges, they repel away from each other, hence why there was movement of the alpha particles. And finally, what we had was some would go in, they would actually make contact with something and deflect back out, okay, from the direction they'd just come from. Now, that showed us that the nucleus carries most of the mass of the atom in that center. Okay, so there was actually something that it was making contact with and deflecting back. So that told us that there was something tangible, something solid in that center, and that's what that developed knowledge of the understanding of the nucleus. So, from Ernest Rutherford's gold foil investigation, and based on these interpretations here, there was a change made to the model of the atom, and that model of the atom was known as the nuclear model. So as you can see here, what we had our central nucleus, which I'm just demonstrating to you here, that central nucleus, and at the time that was understood to be a positive nucleus. We didn't know the breakdown of it. At this stage there was no understanding that actually you could break down that positive charge into subdivide it into smaller parts. That did eventually happen, and then that was known as the proton, and there was no knowledge of the neutrons at this point. So we had a positive nucleus, and what was orbiting around the outside of the nucleus was our electrons. Okay, so that was the understanding of the nuclear model. So a progression from the Plum-Punney model, but not what we understand it to be today. So from that, we then progressed further. So what we then had is a gentleman called Niels Bohr. Niels Bohr came along, and what he decided through different experimentation and different investigations, which you don't need to know the ins and outs of for your GCSE, but what he decided and what he realised was that electrons didn't just orbit around like we see here in the nuclear model. What they actually did was they orbited at specific distances from the nucleus. I'm just going to note that here, okay? So that electrons orbited the nucleus at specific distances, and that was really important. So that was the early Bohr model. So again, as you can see here, we've still got that central nucleus that was known to be a positive nucleus, and then around the outside of that, the electrons orbited at specific distances. Then a gentleman called James Chadwick came along, and James Chadwick discovered something very, very important. What James Chadwick discovered was the neutron. Okay, so he discovered the neutron. Again, you don't need to know about the experiment that he created in order to discover the neutron, but you just need to understand that James Chadwick discovered the neutron, and that made further improvements of the model of the atom for two reasons. It helped our understanding of isotopes, so I'll just note that down as well. It helped our understanding of isotopes, and it also led to a further improvement. So the early Bohr model, as I've shown you there, but as I just show you on this slide here, what it then demonstrated is the Bohr model that you've seen above, but what you see now is the nucleus is now not just a positive nucleus, but he's actually showing you that the mass of that central nucleus can be broken down into protons, but also into neutrons as well. If you've got any questions, please leave some questions in the comments below. Good luck with your studies, and work hard. Thank you.